Hello, Math 1050. This is Mrs. Bricky, and this is section 3.6, Polynomial and Rational Inequalities. There are 4 topics in this section. 3 of them are very similar, solving quadratic or polynomial inequalities. And the 4th one, rational inequalities, is similar but a different type of equation. So the first one is solving quadratic inequalities that are written in factored form. So it'll already be factored. Here's our inequality right over here. Our goal is to graph it, to graph the solution. So the first thing you need to do is just visually make sure that you've got an inequality that is comparing to 0. So in our case, we have greater than or equal to 0. And the critical numbers are any values that make the function 0 or undefined. So each of these factors are giving us a critical number for our solution. That first factor gives us the critical number x equals 2, and the second value or factor gives us the critical value 3. So these are your boundary points on our graph. So if our inequality includes is included, then we would have closed circles at those boundaries. If it's strictly less than or greater than, you would have those open. So for our problem, we are dealing with greater than or equal to, so filled in circles at 3 and at -2. Then what you're going to do is test each of those regions. So those points are dividing the number line into 3 regions: region 1, region 2, and region 3. We have to decide if each of these regions should be shaded in or should be left open. So to do that, we're going to just test each region. And most of this you would just do, either on your calculator or just in your head, but I'm going to write it out. So to test region 1, I choose an x value. So I'm just going to choose -5. And it doesn't matter which one you choose, just somewhere in that region. So if I test -5, I just have to think about is -5 plus 2 times -5 minus 3 greater than or equal to 0? And I'm just kind of thinking about that. Well, -5 plus 2 is a negative number, and -5 minus 3 is a negative number. And if I multiply those together, I get a positive number, which is greater than or equal to 0. So this would be true. So because it's true, then we should shade region 1. So this is part of my solution graph. And then you just test the next region, region 2. In region 2, I'm going to test 0. If 0 falls in your region, that's usually the easiest thing to test. So 0 plus 2 is 2, 0 minus 3 is -3, and that is less than 0. That is not greater than 0. So this region, that's not part of our solution, so we would leave it blank. Don't shade that region. To test region 3, we pick a value in there. Let's just test the value 5. So 5 plus 2 is 7, multiplied by 5 minus 3, that's 2. Is 14 greater than 0? Yes, that is true. So we would shade region 3. So our solution graph would look like this, where we have everything from -infinity up to -2, and we have from 3 to positive infinity. You're not going to have to write that interval. You'll just be plotting the graph. All right, so the next ones are polynomial inequalities. So the last one only had 2 factors. The difference here is that you might have 3 or 4 factors, but the idea is the same. Make sure you have a comparison to 0. So we do have a 0 on the right there. Find your critical numbers. So our critical numbers are -6. Now this one's a little tricky. The last one is 4. If you have something like this factor in the middle and you aren't sure, remember that we are just setting that factor equal to 0 and solving it. So this is x equals 1 for our critical number. So we found our critical numbers, our boundary points. They occur at -6, 1, and 4. Make sure you get those in the right order. I've been known to make an error like putting things in the wrong order, like accidentally putting a -4 and then a -6. So just be really careful on your number lines to get them in the right order. So we just need to test each boundary now. And again, you will probably just do this sort of in your head. And you can almost test it, since we're comparing to 0, you can kind of just test it for positive and negative. I'll show you what I mean. So if we test this first region, so we're going to test right here. Maybe we think about the number -7. Well, if we sub in a -7, I'm going to write up here by my function. If I sub in a -7, that first factor is a negative number. Subbing in a -7 here gives me a positive number, and subbing in a -7 here gives me a negative number. And our question is that less than 0? So a negative times a positive times a negative is a positive number. And so it is not less than 0. So we would not shade that region. So let's test the next region. The next region is from -6 to 1. So we can test 0. So if I think about up at the top, again, I'm going back to my function and thinking about subbing in a 0, this becomes a +6, a +1, and a -4. And our question is this less than 0? And we have 2 positives multiplied by a negative. So that is a negative number. It is less than 0. So this is part of our solution space. Now, I guess I set up my number line, but I never filled in my ends. These would be open circles on each end because it is strictly less than 0. All right, so I need to test every region. My next region goes from 1 to 4, so I'm going to test this region. Maybe we kind of think about the number 3. So thinking about subbing in 3 to my function, and I really just have to worry about the signs. 3 plus 6 is a positive number, 1 minus 3 is a negative number, and 3 minus 4 is a negative number. We're wondering, is this less than 0? And the answer is no, it is not, because a positive multiplied by a negative is positive, which would be greater than 0. So we would not fill in that section. And our last section is from 4 to infinity. So maybe we test the number 5. And we think about if we subbed in 5 here, well, this would be positive 11. 1 minus 5 is a negative number, and 5 minus 4 is a positive number. And so that definitely is less than 0, because that will be a negative number. So we would shade this last region on the boundary. That's an open circle. Now this one, I'm creating a graph to help me answer the question. But on this one, our answer is our interval notation response. So we would respond with the answer -6 to 1 and 4 to infinity. So we just tested each region in order to get our answer. Now, you might have noticed or thought to yourself on these last two examples that these are alternating. Yes, no, yes. No, yes, no, yes. But please do not assume that they will alternate because it doesn't already alternate or doesn't always alternate. So here's an example of when it would not alternate. So this one has four factors, strictly less than 0 again. So our critical numbers are 1, -2, and +3. So this is a good example of where to not put your number line in an incorrect order because I'm known to make that error sometimes. So it's easy to do. It's easy to make that error. Don't just start putting your numbers down like this. They are not in the correct order. Surprisingly easy to do. So -2 would be our lowest, then 1, and then 3. Now, this was strictly less than right here, so these are going to be open boundaries. So I'm going to put my open circles there. We need to test each region. So in this first region over here, we're going to test a -3. And again, we just have to worry about the signs. This first factor is squared. So even if this ends up being a negative number, it's squared, so it's going to be positive. So this is positive. -3 plus 2 is a negative number. Oops. And then -3 minus 3 is also a negative number. Our question is that less than 0? And this is a no. It's not less than 0. So we don't shade the first region. The next region right here, it includes 0. So we can think about 0. 0 is a nice easy one to think about. So again, this first one is always positive because it's squared. Second one is 0 plus 2. That's definitely positive. Last one is 0 minus 3. That is negative. Is that less than 0? Heck yeah. So this region that included 0 would be shaded. And again, you aren't necessarily writing this down. You can if you want, but you at least just need to think about that, even if you aren't writing it down and just thinking about it in your calculator. In this next region, probably the easiest thing to test would be 2 because that's the only integer in that region. So if we test the value 2, again, that first one is squared, so that's going to be positive. 2 plus 2 is a positive number. 2 minus 3 is a negative number. And that is less than 0, so we would shade that region. So you can see right here, it did not alternate. It's those two in a row. The last region would be, we need an integer that's greater than 3, so I'll test the number 4. The first factor is squared, so it's positive. 4 plus 2 is positive, and then 4 minus 3 is positive, and that's definitely a positive number, which is not less than 0, so we would not shade that region. So to report our answer here, we would say from -2 to 1, union 1 to 3. So we would have to have that broken up into two pieces. Now, if our inequality had been less than or equal to, the way that this would change, all those test regions would be the same, but the thing that would change is that our boundaries would have been filled in. Filled in, filled in, filled in. And so then it would be a much different answer because the answer would end up being from -2 to 3. So really watch whether you need to fill in those boundaries or not. Okay, the last topic is solving a rational inequality, and we're going to do two examples of that because it is a little bit tricky. So for starters, in this topic, I think in the other topic, you almost always have it equal to 0 to start with. But in this topic, it's not. So we are going to have to manipulate our equation a little bit so that we are comparing to 0. So I'm going to subtract 2. So I have 4 over x minus 3 subtract 2 is greater than or equal to 0. So I have my 0 now, but this is not a very useful form of the equation. I need to get a common denominator so I can combine those two terms together. So that gives me 4 minus 2 times x minus 3 over x minus 3 greater than or equal to 0. So I do have them combined now. I want to clean up my numerator a little bit by distributing that negative 2. So this gives me 4 minus 2x plus 6 over x minus 3 greater than or equal to 0. So finally, if I combine the 4 and the 6 together, I have, and I'm going to write it over here, negative 2x plus 10 over x minus 3. Okay, so this is an interesting case where, we do have I guess two little expressions that are going to give us our critical numbers, but one of the critical numbers is coming from our numerator and one critical number is coming from the denominator. So even though this is greater than or equal to, which might lead you to fill in the boundary values, one of our critical numbers is coming from the denominator, so it cannot equal 0. X minus 3, we can't divide by 0, so x cannot be 3. So that would be an open boundary on our graph. Alex isn't asking you to create a graph for your answer, but creating a graph will be the easiest way to get your answer. So our critical numbers come from negative 2x plus 10 equals 0 and from x minus 3 equals 0. Open. X minus 3 is an open boundary because we can't divide by 0. So we need an open value, an open circle there. For 2x plus 10 equals 0, negative 2x plus 10, we're going to subtract the 10 and divide by negative 2 to get x equals 5 as our other critical value. So if we plot that one, for that one, that is a filled in boundary. And the reason that one is filled in is because if we think about subbing a 5 into that equation, well, I guess we should, it is exactly equal to 0. So the reason that one is filled in is because, we have that equal part. It's greater than or equal to 0, and 5 causes the function to be equal to 0. Okay, so I never labeled my 5. Okay, so we are going to test each region just like we have been. It's kind of interesting to test these because we're going to be testing a fraction right now, but we can test them the same way that we have tested other things. Let's see, let me get rid of that stuff. Okay, so our first region that we need to test is this region over here. I'm going to go ahead and test 0 because that's an easy one to test. So that means negative 2 times 0 is 0 plus 10. So my numerator is positive. On the bottom, I have 0 minus 3, so that's negative. So our question is, when I take a positive number and divide it by a negative number, is it greater than or equal to 0? And the answer is no. So we don't shade this far left region. Okay, I'm going to think about this region in the middle here, so I'm going to test the number 4. So negative 2 times 4 is negative 8 plus 10 is 2. That's a positive number. And on the bottom, I have 4 minus 3. That is also a positive number. Is a positive number divided by another positive number greater than or equal to 0? Yes, it is. So we would shade that region in between the 3 and the 5. And then our last region is that region that's greater than 5. So we would maybe test the number 6. So negative 2 times 6 plus 10 is a negative number. And 6 minus 3 is a positive number. So is that greater than or equal to 0 when I divide a negative number by a positive number? No, it is not. So we have our final answer on our graph right here. Our final answer would be from 3 to 5, parenthesis on the 3 side, bracket on the 5 side. Okay, let's try one more of those. So again, our first step is to always make sure it's compared to 0. And this one is already compared to 0. It's less than 0. So we need to find our critical numbers. So our first critical number is x minus 4 equal to 0, which gives us the critical number x equals 4. This one is open because this is a strict inequality right here. We cannot have equals 0. It has to be strictly less than 0. Our other critical number comes from our other factor. So x is equal to negative 6. And that one is definitely also open because it is from our denominator, and having an x value of negative 6 would cause division by 0, which is undefined. So both of these are open circles. Alex isn't asking you to create a number line, but a number line will help us get our answer. So negative 6 and 4 were our critical values, and those are both open circles. So we have 3 regions to test. Let's start left to right. So I'm going to test negative 7 for that first region. Again, we just have to think about, is it positive or negative so that we can compare it to 0. So if I sub in a negative 7, the top is a negative number, and the bottom actually ends up being positive because it's negative 7 minus 6. So it's actually 1, which is a positive number. A negative divided by a positive is a negative number, so it is less than 0. So that would be part of our solution. So we'll shade that region. The next region includes 0. So that's an easy one to test if your region includes 0. On the top, 0 minus 4 is definitely a negative number. On the bottom, negative 0 minus 6 is also negative. But when I divide a negative by another negative, I end up with a positive number. So that is not part of our solution space. The final region, from 4 to infinity, we could test 5. So 5 minus 4 is positive. Negative 5 minus 6 is negative, so we're dividing a positive number by a negative number, and that is negative, which is less than 0. So that is part of our solution space. So our final answer for this one would be from negative infinity to negative 6, union 4 to infinity. All right, so let me know if you have any questions on this topic. That is it for lesson 3.6.